Hey everyone, so welcome to episode 2.5 of Teaching a Computer Conlang. We will be making romanizers, unromanizers, syllabifiers, and building n-grams based on phonemes and syllables. So I'm excited. Let's get right into it.
All right. So Delaney has a lot of digraphs. So we're just gonna put them here. So romanized digraphs are da, da. Is this markdown? Romanized digraphs are da, da, draw, cha, ra, sha, ra, ya, nya, na. Is that it? Yeah, I think that's it. And then the unromanized versions of these, it does not have to be the actual phonemes. I don't even think. So I mean, we can, because why not? But then like for this, it would have to be that, but that's 2 characters, and I think it's best if we do single character encodings for the phonemes, because like you saw with the character model, it's a list of single characters. So yeah, so maybe we just make this like Z, because Z isn't used in Delaney otherwise. And then we can make this C. We can make this still C maybe. This can just be itself. This can also just be itself. Same with all of these. I think this is, I'm trying to figure out where this is in my IPA keyboard. Nope. There we go. And then I think this would be, yeah, awesome. Cool. Yeah, so let's do that. So let's define a function called unromanized. So this takes a romanized text and it outputs the unromanized version of the text. So for word in text, for I in range length romanized, or romanized. I mean, it doesn't matter because they're the same length, but yeah, whatever. We could have done either. Word equals itself with replaced. So this is just going through the word, replacing each instance of one of these romanized digraphs with one of these unromanized digraphs. And importantly, it's going this way to this way. And the reason that's important is because I think there are probably some instances of like RCH instead of just RC. And what this will do is it will go through CH, turn it to C. So it will make RCH into RC. And then the next step will turn RC into this, which is what we want. Yeah. Word equals. So this word, this is just splitting the word into its individual characters now. Yeah, so I think what we need to do now is, Delaney has 2 archiphonemes. Basically, it's like a nasal that assimilates to the consonant after it, and a geminate that assimilates to the consonant after it. And at the end of words, the nasal is just, I think it's actually, I mean, like phonemically, or not phonemically, phonetically, it's like that at the end of words. And then at the end of words, phonetically, there's a lot of variation with this one, but it's usually something like L or a tapped R. But otherwise, they're just geminates and nasal assimilation to the consonant after them. Unfortunately, this means that it could be represented as like MB or ND in the script. And then of course the geminate is just whatever is after it. Like here in Chidago, that's the geminate archiphoneme. This is the nasal archiphoneme. And annoyingly, they can occur at the start of words too. So yeah. So we're gonna try to fit this here. So let's make a class called consonants. I guess we just, we really have to go through and like list all of the consonants. Okay, I guess so. Maybe I'll skip this part for you, but actually what we can do is I can go up here. I can say consonant string equals M, N, B, D, J, da, da, ga, pa, ta, cha, ta, cha, ka. Oh, I already have sa, sa, ra, wa, la, ya, yeah, no, yeah, no, and then I'll have I do think there are RL in here, the retroflex. I'm not sure where that is in my keyboard, so I'll just do this thing, the viewer lateral. And then I'll include the two archiphonemes, and, or I pronounce that like it's IPA counterpart, but the two archiphonemes, geminate and nasal. Yeah, similar, like very similar to Japanese with these two archiphonemes. I mean, other than that they can occur at the start of words, but and their word final realizations. But yeah, yeah. Okay. So we have. Oh, that's why I was trying to make a list. So now I can just go like, list cons or print list of consonants. Thank you. And now we can go over here and say, this is consonants. Bye-bye. Awesome. And then we already have our vowel list because we made it for our stress thing up here. So we already have a vowel list, which is awesome. So we're gonna say if the first, or if the index, if, you know, whatever character we're at is a consonant, and the next character is also a consonant, and this is the reason why we can't be on the last character of the word, because then there wouldn't be a next character. If the first one is a nasal, or maybe even the retroflex nasal, which would be this. We're gonna replace it with the archiphoneme. Actually, wait, we shouldn't do the retroflex nasal yet because we want to preserve the fact that it's retroflex. So we want to like somehow move that quality onto the consonant after it. So this is replacing non-retroflex nasal codas with the archiphoneme before consonants. So then we can say, otherwise, if the character is the retroflex nasal, the same thing happens, but also, I think we need to make lists of dental and retroflex consonants, unfortunately. So dental would be N, da, da, ja, ta, la, and then retroflex is na, da, draw, 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 and I think we represented this with the viewerized lateral. Okay, so we'll go, we'll say for each thing in dental, we're using n because we're already using I in this function, so we can't use it again. Where I plus 1 equals, so this is like the consonant after the nasal. Replacing dentals with retroflexes. So it looks like a dental because, like, you know, in my romanization, I wouldn't have RN, RT to signify a retroflex cluster like that. Instead, I would just have RNT. I think this just barely appears, but there would never be NRT, by the way. But it probably barely appears, if ever, but I just want to have the possibility that we'll encounter it. LF word. So this is if they're the same. So this is going to be for the geminate thing. It's a geminate. So this does, like, I think we will be left with like this kind of thing, but it's unclear phonotactically which of, if we have an NN, whether it's geminate N or nasal N, it's unclear phonotactically in Bellini, so it's fine. Awesome. All right, so now let's do the end of word stuff. So if word, the last element in the word is L, we're changing this to the geminate archiphoneme. And then if the last element of the word is N, I think I'll put N and NG, because we did see NG before. Well, actually this wouldn't work, but hopefully it's fine. We can just put N. Word -1, so that's the last thing in the word, is the archiphoneme. The reason I'm making it the archiphoneme is because syllables can't have N as a coda. They can only have the nasal archiphoneme as a coda, and we want this when we're generating, or when we're splitting things into syllables. We don't want words like sanpa to be okay. Only words like sampa. We don't want words like samta to be okay. Only words like santa or Santa. Okay, got myself into that one. All right. Yeah. So then if the final consonant, so this is for like the NG thing, which I guess might appear somewhere, we're just going to get rid of the G. You have to do this before the end thing though. And we have to say if. Awesome. So now words should all be of the right shape, you know, with no weird romanization stuff. So yeah, I think what we can do now is we can say word is itself, you know, joining, because we split it up here. We split it, so we're joining it back together. Okay, so if this is actually a string, we want something to turn it into a list, so that we can do this with it, a list of words. So we'll say if is instance, what we inputted is, if it's a string, we're going to turn it into a list. But that's all we need. Okay, awesome. Oh, so this is for each word. So I think we need something else. We need to say, let's define mini word list. is a list. And then up down here we'll say mini word list append word. Unromanized text is our mini word list joined with spaces. And that's what we're going to return. Oof, see how hard, like, that's so annoying. Like, this program is just so annoying to write. So it's a clean program. So now let's try some romanizations. Let's try to romanize, or let's pick a random word and then romanize it. So this was our random word picker up here. And so let's just try to print this, but romanized. Or wait, what did we call this function? Unromanized, sorry, unromanized. Ripa, that's correct. Me, yeah, fine. Mankaragi, so here you can see that it changed the coda N to coda nasal assimilation archiphoneme. Dora, Mungu, awesome, same thing. And so this isn't phonetic, right? It's just phonemic. Bashikashi changed the SH to its, singular phoneme encoding. Same thing with the geminate archiphoneme. It worked. Shire shire. Jis. Ya. I. Na. Ga. Sorry. Ji. Ni. Ni. Wa. Wada. Okay, so it seems to be working. Lika. Awesome. Alright, so what this means is that hopefully we can generate a next token predictor for phonemes. So basically we'll just go to character list and we'll just say, hey character list, or actually phoneme list of phonemes, obviously excluding punctuation. I'm gonna say including spaces. So phoneme list equals, or let's go for, so say for word in word list, unromanized word is, unromanized word. I guess we have to do this after. Okay, and then we'll say, we'll make our list phoneme list. Or let's have this be encoded word list. I'll say n word list. So then we'll say n word list and unrom word. We can join our n word list into a list of phonemes. So phoneme list, including spaces, is join, oh, what is that? Okay, join n-word list. We can print the first few parts of phoneme list, the first 50 characters or so. Awesome. Bang. Chinyo. Can print even more. Chinyo. Si. Mona. Okay, so it does doesn't do the geminate for this. It does the nasal archiphoneme, which makes sense because we did that rule first. Roni. Baroni so jirao sewatal. Okay, so it treated that well. Awesome. It looks good. So now we can just make a phoneme model. Or let's do this. Print phoneme model. Phoneme list. It should work even though I didn't do that yet. Yeah, it did. All right. Ka, ling, kisatu, lupa. Okay, and we can also, we should also make a function that does the opposite of romanizer, that romanizes things so that we can get from this back to, you know, the romanized version. So let's do that. Basically, we just should be going in reverse. Yeah, I think we should do this first and then this, because we're actually just doing the exact opposite thing. So if word, the last element in the word is the archiphoneme, we're going to turn it into N. If the last element is this archiphoneme, we're going to turn it into L. Or no, for I and for each character in the word, if that character is the archiphoneme, is the nasal archiphoneme. So we need to turn it into either M or N, but I think we need, or RN, I guess. I think we need another category. I think we need to define labial. Yeah. B, P. Is that the only? Oh, I guess W, because I think I actually have both NW and MW in this corpus. It doesn't really matter that much, but MW I think is what I said it was realized as. So you get patterns with labials, W patterns with labials. So I'll say, yeah, W's in labial. If the next character is in labial, word I equals M. Otherwise, if it's in retroflex, we're gonna try to turn a sequence of N archiphoneme retroflex consonant into retroflex N normal consonant or dental, so that we can create this as the romanization. So we'll say word I equals retroflex nasal, and then for N in range, for all of the retroflexes, the next character is itself, but replaced, replacing all retroflexes with dentals. Oops. Yeah. Just mark this so we make sure we know like what we did. We're changing that to that. Else, so this is just before any other consonant, it's N. And finally, if the last consonant is, or if not, we're not talking about last consonant, sorry. If we have our geminate archiphoneme, it's just going to become whatever is after it. Unfortunately, this might give us things like that when we're trying to geminate to that or that. I'm actually not sure how I write it. I'm actually not sure. Yeah, we'll have to see. I don't know if this exists in my corpus. And finally, we'll do the first step of the other thing, of the unromanizer. Awesome. So then let's go up here and let's say, our romanized Gen. Okay, so our phoneme model predicted via kakra sruanin, so something, and we got romanized via kakra sruanin. Awesome. So that seems to work. Awalan. Daigmosha or Daigmosha Mauso Shomag something. Presumably there's something after this, right? It got cut off. Awesome. So we did phonemes. Now the only thing left to do is syllables. Wow, this is going to be a much longer video than I thought it would be. I thought I was splitting this stuff up into, easier steps. I was originally going to do n-grams and CFGs in the same video, but I guess not. Yeah, syllables. Time to make a syllable program. Okay. Yeah, let's make a syllable program. Syllabalizer. Cool. So, I think the syllabalizer is only going to work with unromanized things or phoneme encoded things because, it's easier that way. So, function for getting the syllables of a word. So let's first put spaces between consonant clusters. So unclustered. Putting spaces between consonant clusters. So for I in range of the length of the word, so first we just add each character from word to unclustered word. So if it's not the last, like if there's something after it, we're going to insert a space between them. Space. If the thing we're on right now is a vowel and the next thing, or sorry, the previous thing is also a vowel, so like chua, we'll make there be a space after it, because that should kind of be a syllable break. Then if we're on the first thing, and there's more than one thing, there's something after it. If the first thing is a vowel, and the next thing is a consonant, and the next thing is also a vowel, so like in words like avatar, we're also going to add space. So this is a rule that says, and hashtag here stands for start of word. We're changing this to, we're inserting a space there between syllables. So this has some syllable spaces. List of syllables so far, and then we're going to say for each syllable in our list of syllables, new syllable is a empty string, but we're going to add to this. So we're going to say for I in each syllable or current syllable. This is basically what we did above. So if the character that we're on right now is not one of the last two characters, so as in there are two things after it, and this is important because we're going to say we're going to reference the two things after it like this. I think we're going to say no, it's going to be the same thing as before. So it's just kind of like this rule, except not at the start of the word. So if there's VCV, it will turn into V space CV. Okay, so now we're splitting by spaces again. And now we're just flattening our lists. If a certain syllable. Okay, so this, I'm not sure if this will work. We'll see if this works. I think this is basically, I'm trying to write code that flattens the lists. So right now we have a list unclustered, and a list new sill. And new sills are kind of, unclustered is a list of new sills, but some of the new sills are lists of syllables in themselves. So we're just trying to flatten the lists. Again, this is not like, this is the kind of thing you can like look up on Python tutorials online if you want, but yeah, it doesn't matter too much. I'll of course link this workbook in the description of the video. So yeah, this is gonna flatten lists. Okay. I mean, let's just see if this works. So let's generate some random words and get the syllables. So print get syllables, unromanize word list, random integer. Okay, so yeah has one syllable. I mean, like, it could be argued to have two syllables, but like with the phonotactics that we want to, we're trying to make the phonotactics as easy as possible for the computer to understand. And unless we really want to have it treat as a separate syllable, which I don't think I want, then I think this is good. So another one, dala, it's splitting by syllables. Third one, wa, okay, that's also one syllable. Give me some long words, come on. Oh, so many one syllable words. Oh my god. Okay, see, okay, this is interesting. So right now it's splitting. I mean, I did this on purpose, but I mean, we could have chose not to do this, but I did this on purpose. I think it's fine if we separate syllables this way, so we treat si as if it has 2 syllables, even though it probably only has 1, like really phonotactically. But I think it will be interesting if the computer predicts things based on the idea that this is 2 syllables. That this is like the coda of one syllable, and this is the onset of another, or the onset of nucleus. So let's try one more. Oh my god, I want like a long word to show. But oh, okay. Couscous. I think that was my translation of couscous. Okay, salna. Okay, that's pretty good. Yeah, so it's hopefully marking syllables correctly. So finally, now what we can do is we can create a list of syllables and do the same thing we did for all of these down here. 4 syllables. Syllable model. I don't like how all of this is like grayed out because we're doing it after we wrote the program, but you know, it's fine. Syll list. Okay, well, we have to create a syll list. I'm using 1L because like if there's 3 L's, it's just hard to understand. So I'm just gonna use 1L here for our syllable list. I think it'll be word. Yeah. So syllable list. We should define our syllable list. We can define it down here, I guess. Like we did the phoneme list. What do we have on there? Okay. Or we don't have to do this whole thing actually. We just have to say so list is a list for a word in word list. Syllables equals get syllables from the unromanized word. And then for syllable and syllables, we're going to append that syllable to our syllable list. And then also we're going to, at the end of each word, append a space to this list. Let's look at the first 100 syllables. Dai space, sa space, bang space, ku. Okay. Dao, ta, ru space, e space, no, a, wa, ru space, so on. Okay, that looks pretty good. And then we'll go back up here. We have our syll list. Let's try it. Okay, syllable model. I laiwan tageku oda. Oh, that's interesting. I mean, is this fine? I don't know. Let's Romanize it and see if it's fine. Print syllable gen and then print Romanized syllable gen. Okay. Oh god. Okay. Anyway, so this is actually interesting in the phoneme model because it basically encoded retroflex harmony. Delaney has retroflex harmony, which means that either a word has there are only retroflexes in a word and not dentals, or the reverse. Or there are neither. But here you can see that this word has only retroflexes. And I mean, actually, if I were romanizing this word, I would not romanize the other retroflexes after the first one because you kind of know they're retroflex. but I guess this did. Maybe we can change that later, but not a pressing problem. For the syllable model, that's cool. I want to like make us able to see what it's actually generating, like the actual syllables. So maybe I do text. Okay, so then we can see that all the syllables that it's generating. So nchida. Okay, but then it's romanizing wrong because the spaces. I don't know, it's fine. But I just wanted to make sure that it was doing it based on syllables. Which I think it is. So now it has Janda, Kadami, Isana, Gelangi. So we've made all of our models. Next time we're gonna look at like how these are good and bad. I mean, we've already kind of seen that, like, for example, the phony model tends to generate, or the character model tends to generate really long words. I mean, it's actually doing fine now, but I think that's because we have it as a foregram model. Well, anyway, we'll look at, different types of n-grams, but most importantly, first of all, we can check this off. That emoji was perfect for the situation. Okay, first of all, we're going to evaluate all of these n-gram models on context-free grammars for the CKY parsing algorithm. You don't have to know what this means. Basically, this just means like we're going to see how well these models actually model the Lini phonotactics and syntax. And then we're going to use the tools that we were using to evaluate them to actually generate new syntactically grammatical and phonotactically sound words and text in Duolingo. Whew. So yeah, that was a lot. Yeah, that video was way longer than I expected, but I guess this is how it's gonna be. I hope you guys are still here following along, or at least some of you. I'm gonna put the link to this notebook in the description. And you can, fiddle around with your own conlangs, and I'd love to hear like how, the syllabalizer, the romanizer, what problems you run into in your own conlangs. And I might have to modify them a little for the context-free grammars, so we'll do that next video, but yeah, so, and I wish you all luck on the unfortunate task of corpus creation, which for me was literally just me sitting down and like typing everything up, copying and pasting. Yeah, so I hope you guys had fun. I hope this is useful for people. So yeah, see you guys next time.